Yash Nathwani and I am your math instructor, and we are currently studying chapter surface area and volume. So today we are going to take a look at a surface area of a three-dimensional shapes, which you can see on your screen. Now two-dimensional shapes have only one surface, but three-dimensional shape can have a multiple surfaces. Now surface generally means the outer part or a uppermost layer of anything, right? In Hindi we can say surface as a satah, right? So let's quickly revise what was area. Area was measurement of space occupied by any surface, and surface area means measurement of a space occupied by all the surface of any particular three-dimensional shape, right? So if we have a two-dimensional shape, we can say we have to find area. But if we have three-dimensional shape, what we will say, we have to find surface area, right? Because three-dimensional have multiple surfaces. So surface area of all that surfaces combinedly give us a surface area of particular three-dimensional shape. So surface area, as I said, is divided into two parts, that is curved surface area and total surface area. Now curved surface area means area of only curved surface leaving the top and the base part, right? Means this top part and here there will be a base part that will be not included in curved surface area. Curved surface area will only include this curved part, right? And total surface area means area of a curved surface as well as area of top and base, right? In total surface area, the area of this curved shape and area of this top part and bottom part is also included. Okay, so here in this cylinder, this is curved part, this is top part, and here there will be a bottom part, right? Now if you got confused at this point about curved and total surface area, then don't worry. We will try to explain you it in very easy manner in further video. The first three-dimensional shape we are going to see is cube. Cube is a shape with 6 sides equal. Now let's see this shape in 3D view. So here this is our cube in 3D view. So as we can see, we have 1, 2, 3, 4, here above 5th and here down 6th. Total we have 6 sides, right? So here we can see the 6 side of a cube and all these 6 sides are square. So you can say cube's whole surface is made up of these 6 squares. So here this 1, 2, 3 and 4th surface are curved surface of a cube. Curved surface only includes this face which you can see while I am rotating this cube. And this 5th and 6th are not considered in curved surface. This 5th can be said as a top surface, this 6th can be said as a bottom surface. So when we say curved surface area of a cube, we will just consider this first, second, third and fourth. And when we say total surface area of a cube, we will consider first, second, third, fourth, this 5th and 6th. So now I think you got a general idea of what is curved surface area of a cube and what is total surface area of cube. So curved surface area of this cube will contain first, second, third and fourth surface. And 5th and 6th are not included. So we have 4 square surfaces, right? We have 1, 2, 3 and 4 square surfaces. So curved surface area of this cube will be a square plus a square plus a square plus a square. That is 4 times a square. So that's why curved surface area of cube is 4a square. Why? Because we have 4 surfaces which have a shape of a square and area of a square is a square. So we have a 4 square, that means we have curved surface area of a cube as a 4a square. Now total surface area, we have all the 4 sides including this 5th and 6th sides, right? So in total surface area, all the sides will be included, right? So total surface area will be that 4a square including 2 more squares, that is 4 plus 2, that is 6a square. So therefore total surface area of cube will be 6a square. Okay, so our second three-dimensional shape is cuboid. Now cuboid have three properties, that is width, breadth and height. Which three properties? Width, breadth and height. This longest side is known as width, this inner side is known as breadth, and this tallness of this cube is known as height. So now let's see cuboid in a 3D view. Okay, so here we can see 6 rectangles making the whole cube. You can see first surface is also rectangle, second is also rectangle. Why rectangle? Because both the sides are not same. This is breadth, this is height, which is different. Again, third is also rectangle, fourth is also rectangle, fifth is also rectangle, and sixth is also rectangle. So we can say cuboid is made up of different combinations of different rectangles. Okay. So you can see here this first and third surface are same. Why? Because both of them are made up of width and height. Right? Then these fifth and sixth surface are same. Why? Because both of them are made up of breadth and width. Then this second and fourth surface are same because they are made up of breadth and height. Okay, so as you can see, opposite surfaces are same. As in rectangle, opposite sides are same. In cuboid, opposite surfaces are same. Now for curved surface area, we will take first, second, third and fourth side in consideration. Right? Only first, second, third and fourth surface will be considered. Fifth and sixth will be not considered because they are top and bottom surfaces. Okay, so our curved surface area will be, first surface will have a area of width into height. Why? Because area of rectangle is width into height. So here width is W and height is H. So our curved surface area of cuboid will be, first surface have area of width multiplied by height. Right? Then our second surface will have area of breadth into height, right? Because second surface has breadth as its width and height as its height. So breadth into height will give me area of second surface. So third surface will have area of width into height. And fourth surface will have area of breadth into height, right? So these four surfaces will be included in curved surface area. So here we have 2 times width into height and 2 times breadth into height, right? So we can write it as 2 times width into height plus 2 times breadth into height. Then, and here we can see we have 2 in both the terms, so we can take 2 as a common, and we also have h as a common, so we can take 2h as a common, and then what is left here? Only width, and what is left here is only breadth. So this is our formula of curved surface area of cuboid, that is 2 times h multiplied by width plus breadth, right? So curved surface area of a cuboid will be 2 times h, the whole times width plus breadth. Okay. Talking about total surface area of cuboid, we will take in consider all the 6 sides, right? This first, second, third, fourth, fifth and sixth, right? So we already have curved surface area of these 4 surfaces, right? So we will copy that 4 surface, then we will add this 5th one, that is width into breadth, plus we can say width into breadth again, width into breadth. So this will give me 2 times width into height, 2 times breadth into height, and 2 times width into breadth. So 2 times width into height, then you have 2 times breadth into height, then you have 2 times width into breadth. Now you can see in all these three terms we have just 2 as a common, right? We have width in this term, but we don't have width here. We have breadth here, but we don't have it here. We have height here in second term, but not in the third term. So there is only 2 common in all these three terms. So 2 the whole times width into height plus breadth into height plus width into breadth. So this is our formula of total surface area of a cuboid, right? 2 times width into height plus breadth into height plus width into breadth. So you can write it anyhow, right? You can first write breadth height, you can first write width breadth, you can first write width height. But the only thing you have to remember that in total surface area you have to take it consider all the possible pairs, that is 3 pairs, which is width height, breadth height and width breadth, and you have to add them and then multiply it by 2. In curved surface area we will only consider width into height and breadth into height. This width into breadth, which is this upper part, is not considered. Okay, so our next 3-dimensional shape is cylinder. Now cylinder have 3 surfaces, 1 curved surface and 2 circular surface, right? Let's see cylinder in 3-dimensional view. Okay, so this is our cylinder and this is the first surface, which is a curved surface, right? Then this is second surface, which is circles. See, if you can see this from top, it is completely circular. So our second surface is circular surface, and our third surface is also circular, right? So cylinder have 3 surfaces, 1 curved and second and third is a circular surface. Now cylinder have 2 parameters, that is height and radius, right? Height of a cylinder and radius of cylinder. Okay. Now curved surface area of cylinder will only contain this first surface. This second and third are not included in curved surface area of cylinder. Now you can think about an example that you have a glass which is open from both the ends, right? Just imagine how a glass looks which opens from both the ends. We say it as a hollow cylinder where we don't have this second surface, means it is open from here, and we don't have its third surface, that means it is open from bottom also, right? So at that time, if we want to find the area of that cylinder, then we will only consider this first surface. This second and third will be not considered. Okay, so curved surface area of cylinder is 2 pi RH, right? 2 into pi into r into h, where pi is 22/7 or 3.14. R is the radius of a cylinder and h is the height of a cylinder. Now total surface area of cylinder is area of this curved section and area of this second circle and third circle, right? So we know area of a circle is pi r square. So what we will do, we will add area of these 2 circles in this curved surface area, that is 2 pi RH plus pi r square plus pi r square, right? So what this will give us, 2 pi RH plus 2 times pi r square. Why 2 times? Because pi r square plus pi r square is 2 times pi r square, right? This 2 is not multiplied by 2, it is square. Okay, so now we have 2 pi r as a common in both the terms, right? So we will take 2 pi r as a common and we will have here h in first term, and here there was r square. R square means r into r. So if we take 1 r as a common, we will have here another r. So our total surface area of a cylinder will 2 pi r h plus r, right? So our total surface area of cylinder will be 2 pi r h plus r, right? Or you can simply remember it like 2 pi r h, that is curved surface area, plus addition of 2 times area of circle. Why? Because we have this base surface and the top surface as a circle. So now in some problems there will be a situation where they will give you that you have to find the curved surface area of a tank which is cylinder, but its lid is open. Now lid means ढાંકણું. In Gujarati we tell it as a ढાંકણું. So suppose this second surface is a lid, this first is a curved surface, and third is its bottom part. Now in tank bottom part is covered, but upper part, that is top part, is not covered. So in that case what you will do to find the curved surface area, you will consider this first surface and you will consider this third surface, but you will not consider this second surface. So in that case what we will do, we will just add pi r square one time to curved surface area, right? Curved surface area of cylinder, that is 2 pi r h, and plus pi r square for this circle. So in that case our formula will be 2 pi r h plus pi r square. Now if you want to take something common then you can take, but right now I am not taking. So in the case where one part is closed and one part is open, this will be a formula, and when both the part is closed we have this formula, and when both the part is open we have this formula. Okay, so our next three-dimensional shape is cone. Now cone have two surfaces, one curved surface and one circular surface. Now parameters of cones are radius of cone, height of cone, and slant height of cone, right? This inclined height is known as slant height, this straight height is known as just height, and the radius of this circular base is known as radius of cone. So now let's see cone in a 3D view. So this is our cone, right? Cone have two surfaces, one is this curved and another is this base which is circular in shape. Now if we view from this side, this is height and this is slant height which is L. Okay, so curved surface area of cone is pi r L, where pi is 22.7, r is radius of cone, and L means slant height. Here we have to consider slant height in curved surface area. Now in some problem you have been only provided with radius and height, and you want to find curved surface area. So how to find a slant height? Slant height can be calculated by this formula, right? L square is r square plus h square. Why? See, if you can see here, we can see it is a right angle triangle type shape. This height, radius and slant height combinedly forms a right angle triangle. So here I have just applied a Pythagoras theorem, that is L square is h square plus r square, right? So we can find L by this formula if it is not given in problem. Curved surface area of a cone is pi r L. Now total surface area of cone is curved surface area, that is area of this first surface, plus area of this circle, right? And area of a circle is pi r square. So we have this pi r L, then we have area of plus area of circle, that is pi r square. So here we have pi r as common, right? Pi r in this and pi r square. So here pi r common, so we will take pi r as a common. Here in first term we will have L and in second term we will have r. So total surface area of cone will be pi r L plus r, right? Pi r L plus r. Okay. So next three-dimensional surface is sphere. Right? Sphere means generally a ball. The shape of a ball is known as sphere. Now sphere have only one parameter, that is radius. Right? Why? Because we have only one surface in sphere. We don't have multiple surfaces. Right? So there will be no differentiation between curved surface area and total surface area, because we only have one curved surface area. Right? So curved surface area of a sphere will be 4 pi r square, and total surface area of sphere will be also 4 pi r square. So last three-dimensional shape is hemisphere. Hemisphere have one parameter, that is radius, but hemisphere have two surfaces, one curved and one circular. Let's see hemisphere in 3D view. So here we can see this one first surface is a curved surface and second surface is a circular. Now hemisphere is nothing but a half cylinder, right? If you cut a cylinder from exactly middle, then you can get hemisphere, right? So curved surface area of hemisphere will be half of curved surface area of sphere, that is half of 4 pi r square, that is 2 pi r square. Total surface area of hemisphere will be 2 pi r square plus area of one circle, that is pi r square. Now 2 pi r square plus pi r square will give us 3 pi r square, right? So here we have 2 pi r square, that is curved surface area of hemisphere, and area of one circular surface, that is pi r square. So in total we have 3 pi r square. So our total surface area of a hemisphere will be 3 pi r square. Okay, so this was explanation of area of three-dimensional shapes. Now you should learn these all formulas in order to solve the problem in this chapter. Okay, so I hope you all will remember these formulas. Till then, take care. Thank you.